Section 1.3 is about angle types and segment lengths. Lots of algebra coming up here, but these first four things I think you probably have already seen before, so we'll go through them real quickly. So 4 types of angles. So the first one, acute, is less than 90 degrees. And I guess if I really want to draw, remember angles have a vertex and they are 2 rays put together. And I guess if I really want to make this angle that we're talking about acute angle, then I really should decorate it with a smiley face, don't you think? That's just what happens when you are videotaping and you're in a room by yourself. So, got to keep myself entertained, guys. All right, a right angle formed by 2 rays. If you want a true definition, meeting at 90 degrees. And you could also think of this as like at an intersection. If you're driving a car and the 2 roads are completely perpendicular at an intersection, meet at right angles. So for a picture, here's our 2 rays. Now, I don't care how much that looks like 90 degrees, you never, ever, ever in geometry trust a picture. You trust the information that's given to you. So I hope you remember that nothing is 90 degrees until you put that little corner box in there. Okay, so that box is what tells you exactly 90 degrees. Okay, so keep that in mind. And then a obtuse angle is more than 90 degrees. So it would look something like this. We would be talking about that obtuse angle. And then a straight angle contains exactly 180 degrees. Okay, so that would be like this. And you've heard somebody say do a 180, which means completely turn around. So you're facing going to the right. Also, you need to turn around and you're facing now going to the left. So some people say straight line equals a straight angle. Okay, so 180 degrees. All right, moving on to length. All right, so what we want to know about length is that, move that out of our way. We want to find the length of each of these segments. Now, please understand, I got to teach you right off the bat, this is not a guess and check class. This is an algebra class. It's geometry based on algebra. So you are required to show me work. Okay, that's going to be a big thing on the homework and especially on that first quiz that's coming up. So right now, everything I'm about to put in this video, make sure you're writing it down because it is required work to get credit. So even if you get the correct answer, but you've showed me nothing, okay, because I know what's coming up. I know it's going to get harder faster, guys, so please trust me. You would not get credit. Okay, so please make sure that you're with me. All right, so if somebody was standing at 3 on a number line for this first problem, and somebody was standing at 8 on a number line, and I asked you how far away are they, like how many steps you would have to take. I know you can tell me the answer is 5, right? Okay, but how do I show work? How can I get 5 with an operation using 8 and 3? And I hope you're going to tell me that you're going to say right minus left, or bigger number minus smaller number equals 5. Okay, and let me write that so we can actually read it since the board's not cooperating. 8 minus 3 equals 5. So kind of showing you working down and boxing that final answer, just like homework should look. Okay. All right, so then if we are saying that that is what I should do is right minus left, then up here at the top, guys, you can make a note for yourself to always subtract right minus left is one way you could say it. So always subtract right minus left. Or you could be saying larger minus smaller. Okay, so whichever is going to help you remember it the best. All right, so for the next one then, if I say right, which would be 9, minus left, which is negative 4, when you have a negative negative, you need to put that in parentheses. And then your next line of work, minus minus turns into plus. So we're looking at 9 plus 4, which is 13. Now guys, think about these. If these are lengths, all of these answers better be what kind of answers? Positive, okay? They're distances, they're lengths. So if you get a negative number, you automatically know you're incorrect, so don't move on. Okay, go ahead and go back and fix it. All right, think about this last one. I hope you agree that negative 3 is bigger than negative 18 if you're thinking about a number line. So again, if we're following our process, right minus left would need to be put in parentheses, and then that would be negative 3 plus 18. And negative 3 plus 18, since they're opposite signs, you're subtracting them, giving them the sign of the bigger number. You should get 15. Again, notice it's a positive number. It better be, since it is a distance. So if you're going to summarize here to find the length of any segment, I hope you're going to say this. This is really what I would say that you need to write out as an equation. So right minus left equals, since we're going to need equations in the next stuff, let's go ahead and make it an equation. Right minus left equals length. Right? That's what you're finding if you're putting this in words. Or another way of saying that is the bigger number on the right minus the smaller number on the left equals length. Okay, that's always how you find the length. Bigger minus smaller. All right, so then if we get to this, where now we're doing something a little bit different. We're finding the missing coordinate. So when I say coordinate, for this first problem, we're saying, okay, somebody's standing at 9 on the number line right here. And we want to know where this person is standing on the number line if that length were 4. Okay, now I hope the logic would say that if I am moving 4 steps past 9 in the right direction, that I would be now standing at 13, right? That's the common sense. Remember, I'm constantly going to put an easier problem there so that you can prove to yourself how the algebra works. So you cannot just tell me 13, please. Okay, we need to practice with the algebra. So here's what I would like you to do. Okay, please get on here and label each of these points A and B. Okay, you can call them anything you want, but as long as they're in the picture and labeled. I am trying to find B. All right, so here's what we just said. We said whatever's on the right, which in this case is B, minus the number that's on the left, which is 9, equals length. And they told us the length was 4. All right, guess what? This is a one-step algebraic equation. Okay, exactly what you guys did in your summer packet. And for review, how do I get the B by itself? Well, I need to do the opposite operation. I need to add 9 to both sides. Err on the side of showing me too much versus too less at this point. Those cancel, and that tells you the coordinate for B is now at 13. Box your answer. I'm modeling exactly what your work should look like to get credit. Okay, if we do another one here, let's say we go with this being A, this being B. Think about setting up your equation there for yourself. Okay, so whatever's on the right, the bigger number, minus the smaller number, which is negative 4, so you need some parentheses because it's negative negative, is supposed to equal length. All right, so if we take care of the negative negative, it's going to be B plus 4 equals 10. How would I get B by itself? I need to subtract 4 from both sides. Draw my line. Those cancel. That means B equals 10 minus 4 is 6. Okay, I'll box my answer. Now let's think about that logically. Both of these, we should maybe put the 13 from that first one back up here, make sure it makes sense. 9, if you took 4 steps, would equal 13. If we do the same thing in this one, if we say this coordinate is supposed to be 6, well, if the length is 10, then think about it this way. If this was 0, from negative 4 to 0, that distance is 4. And from 0 to 6, that distance is 6. And 4 plus 6 is 10. Okay, so logically it should make sense. Algebraically it should make sense. Okay. All right, so what's different in this last one? Well, the only difference should be that if we call these A and B, it's just A that's missing, but the process is still exactly the same. Remember, it's always the bigger number, which is supposed to be on the right. So -5 minus A this time, right? That's what's on the left, equals length. All right, you got a couple of ways to solve this. All right, I'm going to go ahead and leave the A on the left, but remember, it's not an A, it's a negative A. So if I get rid of the 5, the -5, I need to add 5 to both sides, making this cancel. I have negative A equals 19. Okay, remember we would never write a 1 in front of a variable, but that stands for -1 times A equals 19. So if it said 3A, I hope you would divide by 3. Since it says -1A, I'm hoping to show the rest of the work. You're dividing by -1. Okay, so the negatives cancel. Negative divided by negative is positive A equals positive divided by negative is -19. Okay, and again, if you went back to the picture, see if it makes sense. -19. Well, -19 is to the left of -5. And in fact, if I was at -5, I would take 14 steps back to the left to get to -19. Okay, so let me be extra certain that you understand. Okay, guys, so we'll write it here. This is no joke. This is required work to get credit. Okay, so do not skip it. All of these are required work to get credit for those types of problems. Okay, so make sure that you ask in class not only about how you do problems, but good question is always, how do I show the work? Okay. All right, you're set and ready.